two different perspectives on verification challenges, right? So verification was a challenge 20 years back. It's a challenge today, and I'm sure it's going to be a challenge 20 years down the line also. It's just that different sets of challenges, right? So next we are going to jump on to another interesting session. So we are going to have an industry panel. This panel is sponsored by Siemens. So what we are going to discuss in this panel is what will it take to fully implement a digital transformation platform for tools, IP, and services, right? So we've put together a panel of industry experts, and this is going to be moderated by Shakeel Jeeawoody. He's a strategic alliances product marketing. He's part of the strategic alliances product marketing SVSD from Siemens EDA. So Shakeel, why don't you come on the stage? Yeah. Shakeel Jeeawoody has over 30 years of experience in applications engineering, alliance and people management, and marketing roles for a wide range of companies in the semiconductor, EDA, and IP industries. Before joining Siemens EDA, he was a vice president of marketing at Blue Pearl Software. Prior to that, he worked for companies such as Fairchild Semiconductor, European Silicon Structures, Viraj Logic, and Cadence Design Systems, and has experience in developing and marketing innovative products and solutions for customers worldwide. So Mr. Jeeawoody holds a MS in Electrical Engineering from ISIM France and an MBA from Anderson School, UCLA. Welcome, Shakeel.
Thank you, Ashok. I think it's very nice for me to be one of the last on main stage, but I'm between you and coffee also. I understand that. But I think you'll see from the panel we put together, it'll be a good summary of all the different things you've heard since yesterday. Before we do that, let me bring the panelists one by one, and then we'll go through their bio. So Srinath Acharya from Excelfore, he's the founder and CEO. Duraiswamy, who is the co-founder and managing director of Mobiveil India. Shripad, Kanni, who is head of the product line for test at Vector. Sanjeev Kumar, who is the founder and CEO of Logic Fruit. So maybe first we'll go through their bio. As you can see, Shrinath, lots of experience. He's been in the technology space for many years, founded a couple of companies, technologist, also MBA, and he's worked with many OEMs. He's also working with Siemens in other capacities. So welcome, Srinath. Next one, we have Srini. So Srini also founded companies. He's worked with GDA, which we know from a long time. In the communications market, he's got lots of patents and experience in that space. Currently, he heads the automotive team in India. More than 400,000 people under his belt. And obviously, you can see from his bio, he's worked at many companies, whether it's storage, compute, networking, and so forth. Next one, we have Shripad from Vector. For those of you who know the automotive space, Vector is a key supplier for test tools. And Shripad has a lot of experience in different companies in the automotive space, whether it's Bosch, Delphi, and so forth. Next one, Sanjeev, also He's from North, IIT Kanpur, working for many years with Sanjeev. He has a very, very nice team that are leading in some of the key interfaces and lots of experience on FPGAs and building system on FPGAs. All right, so before I proceed, maybe some of you who are perceptive notice that there was a requirement to be part of the panel, and some companies could not make it because they could not provide somebody whose first name starts with S. So thank you, guys. We have the fantastic 5 S's. So before I get started, maybe let's talk about the topic, digital transformation and for automotive. So from a Siemens perspective, digital transformation is very wide. It applies to manufacturing, it applies to services, and so forth. But maybe I'll ask the panelists here just to give their thought about from where they do and where they see, what is their interpretation of digital transformation. Maybe we start with you, Srini.
Oh, good morning. Is it audible? Yeah. The way I look at the transformation, not just on the digital, any transformation, it starts with an elite, then it needs to reach the common people. That's where the transformation will have the real purpose. And we had seen in multiple domains that it had come through the way the transformation starts. It would have started at a very small thing, be it a computers. It started in a smaller way. Now it is across all over. And the mobile revolution changed. I think the Qualcomm Joy mentioned about be almost like 1.2 million devices in India. So the kind of thing that it had reached. So that's the kind of transformation that is being looked in. And when it comes to, this is more specific to an automotive thing, I'm pretty sure that that's something which will also get the transformation. And when I was looking at, right, even the smallest devices has got close to 30, 35 electronic devices in it. And a complex and high-end things, it crosses 100 plus control systems. So these has to be simplified and these has to be standardized. So once the way standardization happens, it will help in bringing in as a more prevalent system in the industry. That's my view of it.
The way I'm looking at digital transformation is that this is possibly the second or third generation. Initially, things happen from my automotive perspective when things were going from tape decks to CDs, and then now it's going from having those things into more connected systems. And digital transformation is happening at multiple levels. And it's very important at this point to have standardization, as he mentioned just now. And we are looking at from the way inside an automotive, the transformation is happening from very high-speed networks inside, the connectivity to the cloud and back, and very importantly, the data standardization itself. So I think standardization is very critical in this transformation. You are going to have things like digital twins, so that you can actually simulate things without having to deploy. You can have things like, in the case of chips, how you can deliver possibly a 4G platform today, but have to do nothing more, just update it to a 5G platform. And that is just transformative. I think really the current level of digitalization is, in our view, transformative if you lay the right foundations.
Yeah, I'm out and out automotive experience person here, not a semiconductor or silicon SOCs. So I tell my experience like from a vector point of view. Like when we started vector, the canalizer was the tool. The basic reason why we had this tool is connect to the CAN network and see what's happening on the CAN network. Just see what's happening. You don't need to do anything. That's where we started. Then the digital transformation kicked in the name of Kanni, where we are simulating other ECUs when I'm testing one ECU. I am able to send some CAN signals to the target ECU to test whether the target ECU is exactly behaving as it should be. Come to the current age, 2022 or even few years back, when the much more complex digital transformation is a digital twin, as said here. So we are no more mimicking one ECU, no more testing one ECU, we are testing entire vehicle in presence, virtually multiple vehicles, roadside units, like if it is a car to X kind of a topic, where cars are talking to each other. And there is a OTA, where OE is directly monitoring the vehicle, and in terms of flashing or prognostics, many things are happening. So digital twin is only evolving much higher speed. I see one small interesting point here. The more and more we are becoming lazy, or more sophistication, or more ease of use of technology, the tools are becoming too complex. It is becoming so complex and so heavy. Even the iOS or Android is getting into GBs from mere MBs few years back. So that tells the complexity of the tools are increasing. The things expected out of the tools are increasing just to make our life easy in a complex electronics world.
Thank you, sir. I mean, digital transformers, again, is a very big word, it's not a small word. I mean, selling a car through website, right, to having PCI Express interface inside a car. And it covers basically all the different area. For me, for Logic Fruit Technologies, as we were developing a lot of FPGA-centric system for different industries. So we are seeing a lot of basically requirement from several automotive startups basically to develop customized solutions where they are trying to develop proprietary technologies and they need to validate before it goes into a car, right? So there's kind of a lot of change basically in terms of the automotive applications, which we did, I think, 6-7 years back. It was more of a CAN, FlexRay, LIN, and now people are asking about PCIe and Ethernet and automotive Ethernet kind of high-speed interfaces inside an automotive system. So it's kind of completely changing a car from a very low-speed interface, digital interface, into a very sophisticated high-performance computing machine basically inside a car. So I think for me, as Logic Fruit, I mean, it's all upgrading the digital interfacing, putting all the processing power in an automotive is basically a digital transformer for my point of view, basically.
Can we say automobile is an immersive mobile technology?
Yes, it is going to be actually, I mean, that's what I'm thinking. I mean, whatever we had in mobile, basically, the car is going to have much more than that. I mean, it's going to have all what mobile have, but it's going to have much more than that. It's going to have vision, it's going to have machine learn, AI, it's going to take own decisions. I mean, it's going to be a kind of robot, right? Moving robot, I think.
Excellent. Thank you guys for that quick definition of digital transformation. What I'll do next is each of us going to have maybe 2 slides just to go a little bit deeper into how we are contributing to the automotive industry. And then I will have some questions to spark the conversation, but you have to participate. So I'll start with a couple of questions, and I would love you to start thinking about some of the questions you have. And obviously, Pradeep, our DVCon chair, is here to monitor the best questions. And he has a surprise for you. All right? Like Sanjeev just said, I think it's good that we are doing this as the last one. So if you've been here, the sessions. The first one, synopsis, talk about AI, all right? Then there was Siemens that talked about standards. Then we saw some presentations where the verification challenges of IP, of SoC, of ASICs, but we are moving way beyond that. Like Joyce said, the car itself not just a system. At Siemens, we call it systems of systems. So imagine the complexity of verification for that. So that's what we are here, because in India, there are so many good verification engineers, but we don't have enough. So anybody here in the audience, if you have kids, make sure you put them on the DV track, because we need more verification engineers. And you're going to see why we need more verification engineers, okay? Also, I think Joy set the stage. Verification, it is not just that little chip, that IP that you're doing, but it's system of system that includes all sorts of SOCs with FPGAs, with software, with middleware that you need to test in a hybrid environment. So the definition of hybrid, we are moving it way high up in the scale of what we call hybrid. It is not just software and a little bit of hardware, but there's a lot of complex. We'll go through that. Cadence talked about the 1 trillion transistor. Guess what? This is way bigger than the trillion transistor when you put all these things together. And how do we do verification of those type of systems? We need to be able to be creative. Of course, some of them where we haven't finished debugging will go deeper into maybe RTL. But the others, we need to have higher level of abstraction and be able to connect those together. And that's going to be your challenge. Joey talked about 5G, and we just talked about connected car. So this is just one component of testing the system of a system in a car, because the car is no longer just a standard electromechanical machine. Now it is either you call it a computer on wheels or you call it a washing machine on wheels, but it is a connected something on wheels. Okay? So having said that, let me go over what we see from Siemens' perspective. So we introduced the term of digital twin here, and that's exactly what we call it within Siemens. And if you look at the car, we see maybe 3 big components. One is the sensing part. There are many companies that just focus on that aspect. Companies that are doing cameras for car, companies doing LiDAR and radar and so forth. And then obviously the software that's associated with that. So you have that component because those are things that will be feeding the car. The car will be knowing where it is, and then we need to do the second piece on my slide, which is compute. So once you have that information, yesterday I think somebody talked about sensor fusion. So yeah, you have to fuse those images. And how do you fuse the images? How do you do image recognition? What type of device you use, whether it's a GPU-based device and so forth, are very important. And where do you do those compute? Do you do it, you have a device there, do you do it on the edge, do you do it at the data center? Those are all decisions that architects are going to make. And then more, and obviously, the car doesn't have unlimited power. If you're using all the power to run the compute in the trunk of your car, then it won't go far. If it's an electrical car, there'll be only 5 miles left for the car. So those are all strategic things that can be done. And then the third component of that, so you've sensed it, you've computed, and then you need to take action, the actuation of it. And a lot of that is analog, steering and braking and so forth. But now bringing all that together with connectivity. So now the car is talking to other vehicles, is talking to infrastructure outside of the car, maybe traffic lights and so forth, and decisions have to be made. And as we move into autonomous driving, there's not a driver there, and we need to be able to make those automatically. So that's where verification is extremely important. Maybe you've seen recently, there's a company that's been changing the world in automotive, the T company, and somehow they made an assumption that the size of the stop sign tells me how far I am from the stopping distance. And that was a wrong assumption because all stop signs are not equal. So sometimes the car will abruptly brake and then boom, get hit by the car at the back. And that's what the brain of the verification engineers needs to be put into action to do those type of testing. Okay. So next, so having said all that, when Siemens, when we look at the digital transformation, there are so many changes happening. And first of all, we can see that we need, obviously, lots of test tools to be able to test all the new things that we're putting together. We need different levels of IP. So it could be semiconductor IP, it could be interface IP, it could be the chip that Qualcomm developed could be called an IP as they go being used into that system of systems. And obviously, there are a lot of simulations. The core itself, the development cycle used to be 7 years, not anymore. It has to be shrunk to 1.5 years. How do we shrink that? If it takes 4.5 years to build an FPGA prototype, and you need to finish the whole core, the whole new redesign in 1.5 years, you can't do that the way. So you have to make changes in the way you're doing things. And that's where simulation tools come into play. But for simulation tools to run, you need models. So you need to build accurate models at different levels of modeling and so forth. The other part, as we talk about autonomous driving, is if you want to let the car out by itself on the road, how do you make sure that it's safe? And that's what scenario analysis tools do. So somebody said maybe you need 4 billion miles to run the car in every type of scenario to make it safer. But you don't have the luxury to run 4 billion miles. So what you do is maybe you take your car, you run 50, 100, 200 different scenarios, and then you use scenario tools. So Siemens has some, there are open source tools and that you can use to take a typical scenarios. Let's say you were on a car in a city road and you did 1 mile and you recorded that. Now you can take that in the scenario simulator, you can change it. You can add a cow, you can add a cart, you can add a lorry, you can change it from sunny day to rainy day, you can add fog. So all sorts of things you can do to see how it is going to react. So it cuts down on how many actual miles you are to run the car. So all these are things that are required, and there's not one company in the world that has all of that. So that's what the ecosystem of companies that are already supporting the automotive industry, plus new ones, need to come together to make it a reality, and one of them are hyperscalers. Amazon, Google, and Microsoft, and so forth. As you see, a lot of those things are run in the cloud. Unless you are Mr. Musk and you want to build your own supercomputer, not everybody can build the Dojo supercomputer. So a lot of those things are run in the cloud. All right. Maybe now I'll have no, you can just sit here and go through your 2 slides. Okay? Yeah.
I had spoken about digital transformation has really 3 core aspects. One is in the case of automotive, the in-vehicle networks is very critical. And that is the core basis of what we are developing at Excelfore. So based on the TSN, which is a time-sensitive network, and AVB, which is the precursor to that, that forms the basis for high-speed networking inside the vehicle. And once you go beyond that, then you start building the connectivity to the cloud. So you connect the in-vehicle components, then you connect to the cloud. But there are 2 aspects of it. One is how you push the data into the vehicle with OTA over-the-air updates, and then pull the data back into the cloud through data aggregation. Both need standards. And it's very important that these are the 3 aspects that we look at least from our point of view. The in-vehicle networks, the data standard for up and down, and then finally the data format itself. And that really forms the basis of the software-defined vehicle. And that's where the world is going exactly, was the way Qualcomm was talking about earlier as well. So how do you do that? I mean, do we make our own systems? The answer is, we don't propose that. We really are pushing towards having standardized systems. So AVNU is the one which we have adopted and deployed, which is an IEEE standards body. We are the first AVNU certified Ethernet stack. And in fact, we are also a certification lab for AVNU in Japan. But going beyond, that's for the in-vehicle side. Right? Going beyond the data side, it's very important that you are able to sync on the connectivity between the cloud. So eSync Alliance, something that we co-founded along with big tier ones like ZF, Alpine, and Aptiv. And Covisa, which is the standard for data, which we are coordinating with. SOFI, which is a software-oriented architecture, and also the AutoWare Foundation, which is open source autonomous driving. So those are very critical aspects of what we do, and that's what really leads to deployments to us. So we are deploying with the whole host of companies globally for the in-vehicle side, over 10 OEMs, even in the vehicle to cloud and cloud to vehicle side, over 10 OEMs. So that's really the way we are deploying in our systems. Going beyond that, the reason this whole system will work is because you need to lay a strong foundation for the overall software-defined vehicle. And the way you do that is through scalability. You're driving the scalability with operating systems and various levels of not just one, but multiple compatibilities across the system. Then you talk about scalability across platforms. It cannot just be one. You cannot just take the usual gateway kind of platform. It can be domain controllers. It can be zonal controllers, which are becoming very important now. And that is important for us to deploy. And then scalability across brands. I mean, no car company, at least, has just one model of one car. So it's scaling that. Very importantly, across clouds. So we support all the cloud platforms, the big ones, the Azure, Google, AWS, of course, but beyond, into China as well, into Tencent, Alibaba, and so on. And very importantly, scaling ongoing operations of revenues. And this is very important even from a chip point of view. As I mentioned earlier, if you have a 3G or a 4G and you can upgrade it to 5G, nothing like it. And people are willing to invest in that. And all this will come through standardization, which we are pushing on the eSync Alliance and AVNU side. So, thanks.
Thank you, Srinath. Maybe give it to Srini now, with the clicker.
Just to give what we do, I think we have primarily an IP solutions plus design services company, which focuses on bringing IPs more on the storage side, but at the system side, we are heavily focusing on the automotive space. I think I'll cover a couple of products which we have. We are headquartered in Milpitas, having 3 design centers in Chennai, Bangalore, and Hyderabad. And we are starting 4th one in Rajkot, probably in another 45 days from now. Okay. And some of the things that I talked about, that we have NVMe, flash controller, then we have XPI, some of the IPs that we use, which can be used in automotive space, like HyperRAM. And then we do a lot of system level solutions, be it building a complete system in FPGA-based systems or a SOC-based systems, bring an embedded software on top of it. Then we also do a lot of work on the ASIC design and verification part of it. So this is a brief about what we do as an organization. And a couple of products that we had been, I think, the 2 of the prominent things that had been coming up. One is on the EV side. So we have a battery management system which we had done, and it's productized, and we had been working with a couple of OEMs on getting it rolled out. And this has got, we have built our own battery management algorithm which can scale the whole product thing. The other one, I think I'm pretty happy on this because we have just airlifted our first product out, exported last Friday. This is a robotic system. It's an autonomous robot which currently is being used for disinfection. We have an UV lamps which are used to do the disinfection. We have an NVIDIA system, so we have an AI, and we have on the digital twin, we had partnered with an Israeli company who has got a cloud solutions. All the OTA and other things are done through the cloud infrastructure. And we are also working out on a couple of patents which will be on the dwell time on, based on the scenarios, the way the robot is going to operate is something which we are working on. Thank you.
Thank you, Srini. Maybe Shripad?
I'm better stand and speak because it's difficult otherwise to change my thing. So this is what Vector about. So our mission is the OEs, our suppliers and users to provide an open platform of tools. Open platform means like a different supports different standards and software components as well as services while creating embedded systems. And our claim is our products and services make engineers lazy, I mean more productive so that you do your job much better. Our values lies in competence. We closely work with our users also, OEs or tier ones, and that's under team spirit. Competence is we always try to give the best for the industry in terms of the tool capabilities. The precision is one of the reasons why we are looked as almost like a global, like a golden test device. I think you know what I mean. Then independence, in the era of mergers and acquisition, we make sure that your data is protected. We are not sharing with anybody else. Just a short glimpse about Vector, like we are approximately 3,000 people in the worldwide. We made 948 million euros last year. We are supporting 9,000 customers worldwide. We are present in 14 countries. Last but not the least, we actively participate in different standardization committees like AEF, AR Inc., ASAM, which actually helps us to make our tools competitive as well as comprehensive for your tool usage. Our solutions, I will not take much time, but again, this is what we do. We have solutions for AutoSAR and safety and security perspective with respect to embedded systems, automotive connectivity, with whether it is automotive, OTA, or Car2X, e-mobility, the EV vehicles, then ECU development. We do have some ECUs which can be used for quick realization of your product in the vehicle. Then ADAS system and automotive Ethernet FlexRay, like a basic communication platforms which are used by OEs, tier ones. Nowadays we are also seeing semiconductor companies also using our tools for validating their protocols. Then avionics also we are into. So this is, as I said, our take on digital twin kind of thing. So we have a tool set which can mimic the engines, which can mimic the road scenarios. This week we lost one industrialist because of some issues on the road accident. So we will help you to realize different scenarios and how to avoid or how to mitigate or how to validate your functions. The same thing goes for ADAS and even powertrains like this. Thanks.
Thank you, Shripad. Maybe Sanjeev?
Thank you. Yeah, so Logifood Technologies, it's a 12-year-old company, and we specialize in developing customized solutions based on FPGA and CPU. So basically, heterogeneous system is what we are developing, with focus on high-speed connectivity. So starting with the small automotive IPs like CAN, LIN, we are working on the latest data center protocols like PCIe, CXL, DisplayPort. So that is what we are doing. And we are mainly catering multiple domains like test measurement, automotive, aerospace, defense, with the verticals, but horizontal skills, again, developing computing systems, heterogeneous computing system based on CPUs and FPGAs. And just one of the picture, we are very proud that Logifood is the first company who has delivered solutions for Indian defense. Of course, it's not related to automotive, but just wanted to share that first project has been delivered under Technology Development Fund scheme that has been initiated by Government of India many years back. So this is the picture for that. And this is some of our solutions basically that we have developed. The top one is our own product, which is an heterogeneous platform, again having Intel processor, FPGAs, has a lot of sensor aggregation, symbology generations. And then second is a customized solution developed for an automotive company to test their sensor aggregation chips. As I said, that digital transformation is happening on many places. So, I mean, how you collect data from sensors, how you pass it to computer, they are using all the computer protocol, right? Discord protocol is again a computing protocols which has been used to connect their sensor aggregation. So we actually develop small solutions for customers. There's a couple of use cases basically that I have mentioned. And yeah, we see a lot of opportunity that are going to play a lot of roles in developing a lot of customized solutions with Siemens and some of the Siemens customers. Thanks.
Thank you, Sanjeev. So I have maybe one or two questions, and then I'll open it to the audience. Oh, you have questions? Okay, let's go with your questions.
Excellent discussion. So my first question is, see, you talked a lot about the automotive from the car aspect, but you also see a lot of two-wheelers, and so my first question is, are there any special standards for them, like you have for the car scenario? The second thing I wanted to ask also was regarding the battery management system. I think it was Mobiveil or someone. Again, with respect to two-wheelers, are there any specific standards? And especially I wanted to ask, because you see some of these vehicles on fire or something, right, because of thermal runaway. And do these battery management systems have something to address this thermal runaway at a much earlier stage? How much is that problem solved? And those questions I wanted to understand.
Okay. Maybe you want to take the first one, Shripad?
The question is whether do we have different standards for two-wheeler, four-wheeler kind of thing. There is nothing like that. We don't see any different standards, but the price point of solution is very, very aggressive. So which anyway, I think everybody of us is trying to meet that. It's not going to be easy because if I take a typical car, which is almost like a 10 lakh, and if I offer some solution for 50,000 or 1 lakh, it is still possible to accommodate. But can I offer same 50,000 or 1 lakh solution to a two-wheeler where it itself is a very close to 100% of the cost? You are getting my point, right? So there is a cost pressure. Again, it also does not mean I need to give complete 1 lakh rupees solution. The whatever number of features required is less. Now, what it should be doing is also less. Coming back to thermal runaways of BMS, I can't comment. I'm not an expert to talk about why fire caught in any of these vehicles. But possibly the BMS software is not good enough to evaluate the increase in the temperature. Even if it is increase in temperature, I don't know how to cool it. If it is a four-wheeler, probably you can run some fan. But in two-wheeler, you don't have that capacity or the battery also to run the fan. Again, just assuming. What we are offering is like at least in a development cycle. Vector is not about production side, it is about the development side. So we offer some solutions where you can tap each cell of the BMS battery cells and measure the temperature in the development time. And see under your development cycle, whether it is a cold test or hot test, very high temperature test, you know how battery pack is responding to the temperature or stress test.
Just to add to what Shripad said, a well-designed battery management system is expected to take care of avoiding these fires, right? And an interesting statistics, if you look into the fossil vehicles, has almost 20 times more fire accidents than the electric vehicles. That's a fact. If you look into for a 10K systems that is sold, this is a study that says. So in an extent, it has been taken care. The issue that comes in is a diesel vehicle or a petrol vehicle, when it fires, you will be in a position to douse much better than an electric vehicle, because the lithium ion, which is the core of the battery management system, is more dangerous when it is at an high temperature. So when it fires, the temperature, if you look into it, it is already high. And you will not be in a position to control the battery from thing. That's why if you look into most of the fires that is happening in an electric vehicle, it will completely make it an ash every part of the vehicle before it even comes on. That's the one which has to be looked in. Definitely there is enough protection that has been given, and as he said, all the battery management systems today try to make sure that it monitors each and every cell for all aspects of the thing. So there are multiple sensors that are being induced into the system to make sure that you have enough protection. And we are, in a reality, we are seeing it. But the sad part of it is, if an accident happens, how are we going to control? That is one which is not in our control at this point. But there are techniques where you can do the fault management, right? You can turn off the ignition immediately. But even then, if the battery is short-circuited, there's no way that we will be in a position to control. So that's something, today, do we have a solution? We don't have, we need to figure out how. If the fire gets triggered, I'm really not very sure whether we have a solution. But today, BMS definitely ensures that enough protection is given for avoiding the fire.
I mean, just a final one. So, many of the standards, are there any Indian-specific standards that need to be incorporated into this? Because the way you drive, the sudden brakes, the cow passing by, you have many different scenarios in India, right? So, are there any Indian-specific standards that need to be incorporated, or are they being incorporated into these standards? Are you aware, or?
To my knowledge, I don't think so. Okay. But it's a generic technological thing that, in fact, battery management also, if you look into Excelfore the CAN and stuff, the way battery management is implemented, each one has got their own.
No, not only about battery management, are there any Indian specific standards that are incorporated into the automotive standards? Are you aware of, or there's?
One thing I would.
I think it's a little bit early to go to that specificity.
Okay.
If we look at the automotive industry, in the last maybe 50, 60 years, it's a little bit of a closed system. So starting from the OEM, the car manufacturer, to the tier one, they all had a subset of people they were used to work with. And that created a specific methodology, maybe some format that were specific to those. Now with digital transformation, we're trying to move away from this, at least use the generic standards that was mentioned, and I think Vector is involved with many of those standards, and Srinath mentioned. So we need to get to that level first, and then see as it evolves if there are maybe country-specific things that needs to be done.
If I may add for a few seconds, I think it's important, as the person from Qualcomm said, look at the overall system. Because battery, I mean, I was just going on one trip, and if I was going at 200 kmph, the battery was gone. Whereas going at 60, it will run for several hundred kilometers. So we have to look at the overall system, and that's why, in our view, the data standardization is super critical. Because then you just not collect from battery, you collect from all the key sensors, and then make an overall decision. And that's the way we are looking with our customers, where the question is of get the data and make a decision. And there are two levels of decision making. You make inside the vehicle because you don't want to ship all the data to the cloud, and then you have a decision making there, which can be more of a longer term. I think that's what really the push of eSync Alliance is, to standardize things, and that you can deploy in 4-wheels or 2-wheelers. So.
You had a question? The front row. Questions from the audience? Come on, only one question? You want me to stop? Oh, he has a question. Pradeep has a question.
It's a popular one. How is Tesla going to make it in Indian roads? How is Tesla going to make it on Indian roads?
There is no specific answer. Like, I personally used to laugh. Forget about Vect. I'm not representing anybody here. I used to laugh when I think Tata Elxsi first came with some autonomous car from within premises in Electronic City here in Bangalore. We used to laugh. ADAS in India, no way, no way. And even Tom Cruise literally said in one of the movie, I ate unable to move even 1 inch because there is many people crossing the road because it detects the pedestrian and you can't go beyond, above them. So ADAS is all about that. Now you can see MG, you can see Mahindra. Everybody is coming with ADAS L1, L2. Yes, I can be as cynical as anybody, but technology finally finds a way through our life. The roads are getting better, the road markings will be better, and whatnot. Our next car will be L3 or L4, we don't know. Level 3, level 4 of ADAS. Not current car, next car. So it gets into our life.
People get smarter too.
And even now, if I may
I
add,
think
where we are,
if we want ADAS in our car, I think we all have to start driving according to the rules. I think the major challenge is that we don't drive according to the rules compared to the. So yeah, I mean, yes, for the future for sure. But at least especially for me, I don't see automotive car. Oh, sorry, man, autopilot car basically in India at least for next 10 to 15 years. But it's not only the autopilot things. There are so many other features that's already coming up, right? So there's a warning there's a car behind you and there's a warning if you are running too fast and there's a car in front. So there's already ADAS features that's already available based on, of course, categories. Of course, with expensive cars, you got more categories and less expensive cars, you get less. So slowly, but yes, I think automotive, I'll also like to basically wait for that.
Yeah, I think as you mentioned, probably the highways, it's possible at this point because highways is definitely the infrastructure had improved. But we know the Bangalore traffic, how it is, and then when it pours, it's not going to be something that's going to be. One of the major things that I think that has come pretty well is the auto parking system, right? Which is part of the ADAS. That's something which is obviously doable, especially in all the apartments and other things. That's more easy to adapt in the system. But a full autonomous system in India, I think, is going to take a long time. And as he rightly pointed out, first we need to follow the rules.
Just if I may add, fundamentally it's possible even today. It's a question of what level of sensors you have on the system. If you have the right sensors, that Tesla can drive as crazy as today's Uber driver for me. He was just going, barely moving and turning. It's possible. Today it's possible. So it's a level of sensors and safety you put in. So if you can go within 1 inch of a person, it's possible. So I think, what was that? You can just bring the human intelligence into that. That's exactly the point. So if you can do it, it's possible to deploy, have the right sensors, and forget Tesla. I mean, a lot of companies are doing this now, trying to figure out where they can deploy. Now, a lot of deployments happen inside cities, which are more difficult, as you said, and on the highways it's easier. So, yeah.
one of the features that I currently like, I'm not sure how it's going to work here, is adaptive cruise control. So you can set your speed, I don't know, 65 miles an hour on highway or some roads. And then I was really surprised. My daughter has an Audi Q3. And I was really surprised. Up to maybe 3 miles an hour, it can really slow the car down and not hit the car in front. And it maintains that. And you have 3 levels of control. So like Srinath says, we need to put a little bit more intelligence. But already, you can have 3 levels of control: aggressive, medium, or less aggressive. And it will slow down and accelerate based on that aggressiveness that you selected yourself. So that is already, I think, a nice feature that's already there. It may work in some cases, but if you are not aggressive, it won't move at all in Bangalore.
We can have the Indian driver mode also.
Yes. We have time maybe for one last question. I think I'm already late, but let's have a question.
Hello. Hi, I'm Saurabh from NXP Semiconductors. So I have one of the classic scenario question for you guys, like it's all over internet also. So suppose, like we are talking about autonomous driving, suppose car is now driving on a particular path and there is child, one old man and another animal. So it is imminent that somebody has to die. Means we are now at that age that somebody has to die. So how standards should evolve? Like, should I sacrifice child who is just now born, has a big life to look forward, or old man who has already lived his life 80 years old? Or should I save that person in car who has already spent 50 or 1 crore of money, and should I let him die or save? Like, who one should I save? So how standards should come about it?
The most unhealthy one.
But then other people will feel moral.
No, I'm joking. But the point here is, how will a human make decisions? And you just have to grow with that. With a lot of sensors happening, especially what we do work with V2X, which is a vehicle to infrastructure, you can actually start seeing things much beyond the horizon. So you can see cars in the fog or even way ahead, which 5 cars ahead. Or if they are stopping, you can stop. There are new technologies right now where you have got this peloton kind of trucks which can go literally within centimeters of each other. 5 trucks together, impossible in the past. But if the first one breaks, all of them are breaking at the same time with no time lapse. So,
do you mean this technology can get to that much advancement that no fatalities can occur?
yeah, I think that's where it's heading. The problem is, as you put it, the current vehicles are much more dangerous than the autonomous vehicles. So some of these things will happen which are already happening. We have seen maybe 1 or 2 of those instances.
Okay.
So you know, I like this ethical question, but I don't think we're there quite yet. If you look at maybe the most advanced autonomous driving software company, letter T, and you can see on YouTube, currently, it keeps hitting a child on a crossing. So now you put a child, you put a cow, you put all that stuff. We are not there yet. But that is a very good question for regulatory bodies and to look at these ethical questions once we get a bit further.
I can also answer hypothetically. Let's first figure out trees, plants, cars, and other things. Then we'll come to that question. This is a standard answer. If I want to give a more technical answer, we are looking at ADAS, Car2X, and many other things. Car2X tells you what is ahead of you miles away. So there is no way car will come to close. Like imagine, like in India, you are at. I hope you know this area. You are crossing Iblur Junction towards Silk Board, and your car knows exactly after 15 minutes Silk Board signal is green. So accordingly, your car speed is automatically reduced to 10 km/h. Even if you pedal, no, it is not going ahead because it is here to save the cost of fuel. It is save the total time. It don't want you to wait at a Silk Board signal, but it will make sure that the green signal, what you see in the Silk Board, you are going to cross. Hey, Silk Board, we are crossing.
And to add to this V2X, it is not just looking ahead. With V2X, you'll be able to see at crossroads the cars coming in perpendicular. And if somebody by mistake is going to come when you have a green, that V2X hopefully will prevent you from going if somebody made a mistake. So those are things that are in the works. We don't have it working fully yet, but it's all things that people are thinking about, and that's where verification engineers comes in to go and test those things, make sure they work properly.
Yeah. Thanks for answering my question. I know there can be big brainstorming session on particular exactly this topic. So yeah, hopefully we have that advanced technology.
just to add, I think CV2X, the connected car, is definitely a good solution once it comes in. I think probably 15 years back, we would have not seen what is the shortest route to do maneuver the Bangalore traffic. Now with the maps, we have it. So hopefully in the next decade, we should have all these things into a reality.
Who knows, we have flying cars by that time.
Yeah, and with the connected car, the accident rates, will be going way down with the current rate, right? With the manual driving. So, and of course, yeah, let's see.
So, sorry guys, we ran out of time, way out of time. But thanks everybody, thanks to the panelists, thanks for the good questions. We still be around, so ask questions and maybe we have some time.
Yeah. Thanks all. As Shakeel said, I think the panelists may be around during the break. So if you have any further questions, you can network with them and discuss. Thanks a lot, Shakeel, Durai, Srinath, Shripad, and Sanjeev. I think it was an excellent panel. I think So we talked about primarily about the IP verification, SOC verification challenges, AI, ML. I think this automotive brought up a different perspective. I think So understanding the entire system and how it's going to drive our future. Right. So yeah, thanks a lot for this excellent panel. And also we have one gift planned for the best question. So this was chosen by Pradeep. So we'd like to give that award to Amarnath from CS. Yeah.
Oh, okay. Let's take a picture. Thank you so much. Thank you.
Yeah, we would also like to hand over the plaque and a small token of appreciation to the panelists. So I'm inviting Sandeep Srinivasa, our steering committee member, to hand over the plaques, right? So first we'll start with, we'll start with Srini Duraiswamy from Mobiveil. Go ahead.
Radio A+.
Shrinath Acharya from Excelfore. Next would be Shripad from Vector. Sanjeev from Logic Fruit Technologies. And last but not the least, Shakeel for hosting this excellent panel. I think it was very eye-opening. Yeah, thanks a lot, Shakeel.